Welcome back. If you've been searching for that ultimate SQL full video, zero to expert explainer, well, you've definitely found it. We are going to take all that fragmented database knowledge floating around your head and turn you into a totally confident pro. We're stripping away all the intimidating jargon today, focusing purely on the step-by-step mechanics of how tech giants actually store and retrieve massive amounts of data. You really don't need to be a veteran programmer for this, so let's get right into it. So here's our roadmap for the explainer. We'll look at why files fail us, break down relational databases, build your very first table, unpack the CRUD data framework, filter and query some data, and finally, wrap up with modifying and deleting records.
Section 1. Why files fail us. Before we can really grasp the how of databases, we absolutely have to understand the why.
Imagine this. You walk into a government office, right, and you ask a human clerk to manually dig through a mountain of, say, 1,000 physical folders to find one single property record from 1992. No way! It's practically impossible to do quickly. When data is stored inefficiently, whether that's in physical filing cabinets or just massive clunky text files, trying to pull out one specific piece of information based on complex conditions becomes an absolute nightmare. Now you might be wondering, hey, why not just use Excel for everything? Well, standard spreadsheets are great for small stuff, but they literally crash and burn when you hit millions of rows. They're just too slow. Databases, on the other hand, are custom engineered to handle millions of data points instantly. It's a totally different ballgame when it comes to efficiency. Which brings us to Section 2, Understanding Relational Databases. Let's see how these systems actually organize all that data so securely. Here's a really crucial distinction. You don't actually interact with the raw database directly. You talk to a DBMS, a database management system, like MySQL. Think of the DBMS as a super-powered librarian. You hand over your request, your SQL query, and this librarian sprints into the massive archives, finds your exact record, and brings it right back to you. If you know your way around a spreadsheet, you already get this mental model. It's like a giant puzzle, but the pieces are totally familiar. Think of the entire database as your main Excel workbook. Inside that workbook, you have individual sheets. In SQL, we call those tables. And inside those tables, you have horizontal rows, which represent a single data record, like one specific user's details. Moving on to Section 3, Building Your First Table. Now that we've got the mental model down, let's actually construct one of those digital sheets. Okay, before we even think about adding data, we have to lay down the law. In SQL, we use strict rules called constraints. They're essentially bouncers at the club door, keeping out messy or duplicate data. A primary key is a unique ID for a record. Not null forces a user to actually enter something so we don't get blank spaces. Unique ensures things like email addresses are never repeated, and default just automatically fills in a value if you skip it. And here is what that looks like in the real world. We literally just type create table users and then define our columns inside the brackets. We've got an ID that acts as our primary key, a name that cannot be null, and an email that must be completely unique. I know it looks like hardcore coding, but honestly, it's just a highly precise way of giving instructions to our librarian.
Section 4. The CRUD Data Framework. We have our table built, we have our rules in place, so what do we actually do with it on a daily basis? Literally every interaction you will ever have with a database boils down to 4 fundamental moves: create, read, update, and delete. The CRUD framework. Whether you're scrolling a social feed, buying sneakers online, or running massive enterprise reports, you are just triggering CRUD operations behind the scenes.
Let's tackle create first. To populate our freshly built table, we use the insert command. We tell the database the table name. Here, users. We list the specific columns like ID, name, and salary, and then we drop in the exact values. Boom! We just populated our table with user number 1, Arav, making $65,000.
Section 5. Filtering and querying data. This is the read phase, and frankly, this is where you unlock your true SQL superpowers.
Creating tables is fun, but pulling exactly what you need out of a massive sea of data, that's the real magic. Check out this highly targeted query. We're asking to select everything from users, but only where the salary is greater than $70,000 and the gender is female. We are pinpointing our exact target perfectly. Instantly, the database filters out millions of irrelevant rows. It ignores the males, it ignores anyone making less than $70K, and it hands us back this beautiful, clean table featuring Sneha and Aisha. Try doing that manually with a mountain of paper files.
Let's level up even more. We can stack these commands for serious power. Here, we're pulling from our users, but we tell it to order by DOBDESC, meaning sort by date of birth, youngest first. Then we slap a limit 5 at the end, so we only see the top 5 results. And just like that, we get a perfectly sorted list of the 5 youngest users in the entire database. And to put that into perspective, in a properly optimized system, pulling those 5 exact records out of 10 million takes mere milliseconds. Section 6. Modifying and deleting records. Because look, real-world data is messy. Stuff changes. We make mistakes. Say we goofed up Arav's salary on day 1. We don't just delete his whole record, we surgically update it. We use the update command, set the salary to 45,000, but, and this is absolutely crucial, we specify where ID equals 1. If you forget that where clause, you've just accidentally changed every single person's salary in the company database to 45K. HR would have an absolute meltdown. But because we were precise, notice how Arav's salary drops to 45,000 and our other users like Ananya and Raj are completely untouched. Precision is literally everything in data management.
But what if the whole structure of the table needs to change? Like, say your boss panics because an isActive column was added by mistake, and it's breaking things. No need to rebuild the database. You just use alter table and drop column, and poof, the entire column is wiped out instantly.
You might be thinking, why obsess over this strict syntax? Why not just use visual drag-and-drop tools? Well, for tech giants running platforms like Google or ChatGPT, speed is the ultimate currency. Saving even a single millisecond of query time is massively important when you're handling huge streams of big data. That efficiency is what keeps the modern internet alive. But I want to leave you with this provocative thought to chew on. We've just mastered the manual mechanics of database querying. But as AI continues to evolve and write its own code, how soon will it be before natural language completely replaces the need for us to write these strict SQL queries manually? Will we even need this syntax in 5 years? Or will we just talk to our data? It's definitely something to ponder. Thanks for hanging out with me for this explainer, and keep exploring.